All right. 6-2, day 2. Again, remember you don't have 6-1 notes yet because we are doing 6-1 actually last because I believe that's where that particular section should belong. And so 6-2, day 1 was basically substitution, getting used to it. Because remember, there's no necessarily product rule or quotient rule for the antiderivative. Right? And so we basically, if possible, have to turn the problem into one that we can take the antiderivative of. So a lot of you probably before we would even start this one would say, well, how about we just look at it slightly different and write it more like that. And you can do that if you want, that's fine. Either way, it's going to work out the same. I haven't really done any substitution yet, I've just rewritten it. Can I distribute that x that's out front? I can't because of the 1/2 power. You can't just distribute that through. If I could, that'd be great. We'd almost be done. But unfortunately, you can't. So we are going to go substitution again. And the most common is u is what you use for the substitution. Well, the problem is I don't see anything's derivative there. You know, yeah, if we had an x squared, something's derivative would be there, but we don't have an x squared.
Can you square dx?
Unfortunately, we can't square dx. That's a good idea. But you can only square things when there's like two sides of the equation, and there really isn't here. It's just telling me to do something to this function.
Well, like you do the same thing when you divide it for 2, but just divide by x?
Not quite. You can't put functions on the outside. The question there was do the same thing, but divide by x. Let me show you. U is going to be 2x minus 1. And normally your best bet is for u, if you're confused and you're not sure it's going to work, have u be one of the more complicated things in there. And let's face it, the radical is the most complicated. Well, what happens then is, I think we all know that du ends up being 2 dx, correct? Well, we don't have the 2. So we got to get rid of that. And how do we get rid of this 2 that's on the dx? Yeah, I basically teach to divide by it. I think some of you were saying you kind of make one, and really that's kind of what you're doing. You're making one. Well, okay, so we're good. We've got that substituted for, and we've got that substituted for. Do you agree with that? But I do not have the x substituted for. Can I just leave it in there? Unfortunately, no, you can't. But look at all of this stuff right in there. Do you see an x in there anywhere? Where do you see an x? Yeah, and the 2 right on top. So what we're going to do is we're going to solve that for x. Then we can substitute. So solve that for x. What's probably the first thing you're going to want to do if you have to solve that? Add 1, so it'd be u plus 1 would equal 2x, right? So then you would just divide by 2 to get x. Is everybody okay with that? The comment there was that doesn't help us. Well, we'll have to see if it does. Exactly. We're going to replace that x that wasn't substituted for with u plus 1 over 2. And then is everything at least u's? Now, are we sure this helps yet? Not really. We got to take a look. It might not. So let's go ahead and let's substitute. Well, I think this right here goes in that radical, so it's going to be, or goes right there. So it'll be u to the 1/2. Notice how I've left myself some room. This dx is going to get replaced. It's right here. It's going to get replaced with 1/2 du. And where have we been putting the 1/2? Yeah, get that thing out of there. We don't want to mess with that. Get out of the way. And we'll just put the du over there. So have I substituted everything that's up here? Nope, I have not substituted the x yet, but I'm going to very soon. I'm going to replace it with u plus 1 over 2. Now this is completely your choice, but that over 2, I would personally get that out of there too. Because don't you agree it's really u plus 1 times 1/2 is really what that 2 on the bottom is saying? So what can I do with that 2 on the bottom? We can get it out of there, and it basically turns this into a 1/4, right? And then you got u plus 1 times u to the 1/2 du. Okay, so we've substituted. We still really don't know if this has helped or not. The original problem, we had a radical that we could not distribute into. can we distribute now? Can we distribute u to the 1/2? Yes, we can. Because u plus 1 is to what power? The first. So we went from a problem we couldn't distribute to a problem that we can. Have we really taken an antiderivative yet? No, this is, believe it or not, more just algebra right now. So it's 1/4 the integral of, if I multiply that in.
Excuse me, Dr. Jeff Grossel, please come to the office. Jeff Grossel, the office, please.
U to the 3/2 plus u to the 1/2, all with respect to u. We've turned a problem that we did not know how to take the antiderivative in. And we turn it into a form that we actually can take the antiderivative now. Is it easy? No. And the original, we could not distribute the x through because of the 1/2 power on what was in parentheses. Right, but that's the part we're distributing now. Had there not been the one, if the 1/2 would have been here instead, we could have distributed. But it's the thing in parentheses that had the power, and that's why we couldn't. So basically what we did is we moved where the power was, is really what happened here. Yeah, well, let's go ahead and see what that is. So here's how I would probably write it. Just throw that 1/4 out here. U to the, take it up a power. Well, why don't we just take it up a power? So it's 3/2, take it up a power is 5/2. And then 2/5. Everybody's probably getting pretty used to that by now. When we first did that, that seemed strange. And I know some of you, boy, the substitution seems strange too, but remember when you first did that, that seemed strange, and now it's no problem. U to the 3/2, 2/3, plus a constant. Yeah, now we got to sub it back in. You're right. And what are we subbing back in? Well, any place we see a u, we're going to basically just put back in 2x minus 1. And if I were you, I'd probably put that 1/4 through just to kind of clean things up. So let's just look at what happens for this first one here. If you put u back in, we've got 2x minus 1 to the 5/2. And what fraction really ends up if I multiply this 1/4 in? It really becomes, okay, it could go over 20, but then there's the 2 on the top, so let's just cancel that right away. And just make it over 10. Plus, once again, the 2 is going to cancel with the 4 there. And so there'll be a 2 here, so it's going to be over 6. Everybody see where the over 6 is coming from on that one? Going to be 2x minus 1 to the 3/2. And don't forget your constant. Yeah, basically at the end there, I just distributed the 1/4 just to clean it up a little bit. There is more I could do here. Obviously, we could get a common denominator and all that fun stuff. That's good enough for now. That one right there, I believe, is, as far as substitution is concerned, that's about as hard as they get right there. Because we were substituting, we're like, we got this going great, but where's the x? And it's not that you really make one, it's that you use the x that was already there and just manipulate what it looks like. And here it turned into u plus 1 over 2. And as I was saying, we really changed it so we could distribute. We basically moved to the power legally. I believe that trig is normally the hardest one to decide what's u. You could always try things. For example, if u is 3x in this problem, du is just 3, right? But then you have a sine squared and a cosine. Is it on your sheet? Do you know how to take the antiderivative of sine squared cosine? No, it's not on your sheet. And so you just got to kind of try things and see, well, what's going to happen. And normally what I look for is anything that has a power on it is normally a good place to start. Does anything here have a power on it?
Sine.
Yeah, sine does. Now, does that always work? No, I think the other day, didn't you have a sine squared, tangent squared one or something like that you had to go for, or no, secant squared, tangent squared? And you had to go for secant, right? Well, here, I would suggest that you make u sine of 3x. Because then it's going to be u squared if I put it back in, right? But hopefully du is actually here. And is it? Well, this is actually where I like to review. That's why I like this one, to review something that we haven't done in a while. The derivative of sine is cosine of 3x times 3. Very good. You got to take the derivative of the angle. And then dx. That's what I was waiting for. It's kind of, remember, Trigg's chain rule, basically. Well, we almost have that, though. So is this as hard as that last one we did? No, there's no x that I'm missing this time that I kind of have to manipulate. But there is something that really isn't in the problem. And that's the 3. And so exactly, we're going to go with a 1/3. Now, does this 3 on the bottom, obviously it cancels that one. Does it also cancel the one on the angle?
No.
No. Good answer. And so why don't you try and rewrite that one and take the antiderivative for me?